coprime numbers. Here which pairs are safe? Let us go back to the treasure finding game. In this time treasures are kept on two numbers. MD gets the treasure only if he is able to reach both the numbers with the same jump size. And here is the new rule. A jump size of 1 is not allowed. So both the numbers have no common factor, then we can say that numbers are coprime numbers. If they are keeping such type of numbers, then we can say the pairs are safe. Here that some numbers are given. We have to check if these pairs are safe or not. Now the definition of coprime numbers, that is two numbers are said to be coprime if they have no common factor other than 1. Here we are going to check the numbers 15 and 39. 15 we can write that as 3 into 5. 39 we can write that as 3 into 13. Here we can see 3 is a common factor in both the numbers. So we can say that number is not safe. Next 4. 4 when we are doing the prime factorization, we can write that as 2 into 2. 15 we can write as 3 into 5. Here is no common factor. So these numbers are safe. Next one 18 and 29. 18 we can write as 2 into 3 into 3 in terms of prime numbers. 29 already it's a prime number. So there are also no common factor, which means these numbers are safe to keep the treasure. Next 20 and 55. 20 we can write as 2 into 5 and 55 5 into 11. Here 5 is a common factor in both the numbers. So if they are choosing the jump size 5, he can reach both the numbers. So these two numbers are not safe. So only 4 and 15 or 18 and 29 are safe to keep the treasure there and in this game. So these type of numbers, if there is no common factor, then we can say such type of numbers are coprime. Here the definition is given. Two numbers are said to be coprime to each other if they have no common factor other than 1. Such type of numbers are called coprime numbers. Now here the question is given. Which of the following pairs of numbers are coprime? First one 18 and 35. Page number 116. First one 18 and 35. Here 18 we know that we can write that as 2 into 9, which means 2 into 3 into 3, and 35 we can write as 5 into 7. Here no common factor. So we can write these are coprime numbers. Same way when we are checking the rest of the numbers, we can see that 15 and 37. 15 we can split as 3 into 5. 37 is a prime number. There is no common number or common factor. So we can write these two numbers are coprime numbers. Next 30 and 415. 30 we can do the prime factorization. After that we will get 2 into 3 into 5. 415 is coming 5 into 83. Here 5 is coming in both the numbers. That means we can divide by 5 both the numbers. Or if they are choosing the jump size 5, they can reach both the numbers. So we can write here 5 is a common factor in both the numbers. Therefore that is not, these two numbers are not coprime. Next 17 and 69. 17 itself is a prime number. 69 we can write as 3 into 23. So these two numbers have no common factor. Therefore we can write 17 and 69 are coprime numbers. 81 and 18. When we are splitting, we will get here 3 into 3 into 3 into 3 as 81. 18 as 2 into 3 into 3. Here we can see 3 we can take as a common factor. Also 3 into 3. 9 is a common factor. So there is any common factor, then we can write these two numbers are not co-prime. So the co-prime numbers are 18 and 35, 15 and 37 and 17 and 69 out of these. Here sometimes the first common multiple was the same as the product of two numbers. At other times the first common multiple was less than the product of two numbers. Find examples for each of the above. So sometimes the first common multiple was the same as the product of two numbers. When if the numbers is having no common factor, then the product of two numbers same as the first common multiple. For example, 4 and 5 we are taking, we can see here is no common multiple. Here no common multiple or common factor. If there is no common factor, not multiple, common factor, then we can see the first common multiple. First common multiple is coming, that is 20. 4 into 5. At the same time, the second case, what is coming? Sometimes the product of the less than the product of two numbers. If we are taking, for example, 4 and 6, we know that there is 2 is a common factor. Here 2 is a common factor. So the first common factor, the first common multiple of these two numbers is coming as 12, which is less than the product. Product of these two numbers, 4 into 6, 24, and the first common multiple is coming less than the product if there is any common factor. In the first case, if there is no common factor in the given numbers, then the first common multiple will be equal to the product of two numbers. At the same time, if any common factor for the given numbers, then the first common multiple that will be less than the product of two numbers. Next is prime factorization. Prime factorization of a number, which means we have to write the number as the product of all the prime numbers. Here 56 we can write different way, 4 into 14 or 4 into 2 into 7. Again here we can see the composite numbers are coming. So by splitting again and again the composite number till getting all the numbers as prime, we have to split that and get the prime factorization. So 4 we can write as 2 into 2, 14 we can write as 2 into 7. The easiest method or the simplest method to find the prime factorization of a number is to keep on dividing the number by prime numbers until the remainder is equal to 1 or until the remainder gets 1. In this case, the number is 36. 36 we can write different way or using different tables. 2 into 18 is 36, 3 into 12 is 36, 4 into 9 36, 6 into 6 36. So whatever we are taking, we have to keep on splitting the term. Composite number, we have to split it. Here 2 is the prime number, write the same as that. 18 we have to split as 2 into 9, then that 9 as 3 into 3. Here 12 is the composite number, that we can write as 3 into 4. Again 4 is a composite number, that is 2 into 2. Here 4 is a composite number, 2 into 2. 9 we can write as 3 into 3. Same way here 6 we can write 2 into 3. The other 6 also the same way. After, if we are looking, we can see the final answer in all these methods getting the same. 2 times 2 and 2 times 3. Everywhere we can see that. So here the final answer is containing only prime numbers. For the prime factorization, there is two different methods. One is splitting, keep on dividing the composite number or splitting the composite number till getting the all numbers as prime. 225. 3 into 3 into 5 into 5. 30, we know that 6 5s are, so 6 we can split as 2 into 3 and into 5. Here 72 we can write as 12 into 6. But that 12 again we can write as 2 into 2 into 3. 6 we can write as 2 into 3. Then all together 72 is coming as in place of 12, 2 times 2 and 3. Here in place of 6, 1, 2 and 3. When we are writing here, this is for 12 and this for 6, and rearrange that 3 times 2 and 2 times 3. And another method, the division method, prime factorization till getting 1 as the remainder. So now we can see this is the definition of prime factorization. A number as a product of only prime numbers, then it's called prime factorization. The simplest method to find the prime factorization is the dividing the number by prime factors until the remainder equal to 1. For example, 30 here, that we can divide. 30 is an even number. First prime number is 2. Divide by 2. Then we will get that as 15. Again divide by 3, 5 and divide by 5, 1. So 30 we can write in terms of prime numbers product 2 into 3 into 5. 72 when we are doing here, it's an even number. Divide by 2, we'll get 36. Again divide by 2, 18. Divide by 2, 9. And then after that is an odd number. Check the 3 table. First prime number is 2. Then next prime number. If not possible division by 2, then take the next prime number. That is 3. So 9 divided by 3, 3. And one more time 3, 1. So we can write 72 is equal to 2 into 2 into 2 into 3 into 3. Now figure it out. Page number 120. First question. Find the prime factorization of the following numbers. First is 64. So 64 we can do by splitting that 8 into 8, and 8 again we can split as 2 into 4. This 8 also we can split as 2 into 4. And again 4 is a composite number. So we can write already these 2 same as that. 4 we can write as 2 into 2. This 2 same as that. Here also this 2 same as that. 4 again we can write that as 2 into 2. Now we are getting 6 times 2. So we can write 64 is equal to 2 into 2 into 2. Again 2 into 2 into 2. That means 6 times. If we are doing the division method, 64 divided by 2, we will get that as 32. Again divide by 2, that will come 16, and divide by 2. Divide by 2, it will come 8. Again divide by 2, 4. Divide by 2, 2. Divide by 2, 1. Till getting 1. That means here 3 2's, again 3 2's, total 6 2's. Both the method same way we will get the answer. Now the next number is 104. 104 when we are splitting that we can write as 8 into 13, and this 8 we can split as 2 into 4 and that into 13 same as that. Again 4 is a composite number, this 2 same as that. 4 we can split as 2 into 2 and here 13 same as that. So we are getting the prime factorization of 104 as 3 times 2 and 30. Same thing here, if you are dividing, divide by 2, it will come 5 times 2 in 10 and 2 times. Again divide by 2, 2 times in 5, 4 and remainder is 1. So 12, there 6 times, 1 more 2, here 1 time and here 3. 13 is a prime number, so 13 itself 1. 3 times 2 and 13. Both the methods, we can any one of that method we can apply. This is the by splitting the terms, composite numbers, and this is the division method. Next number is 105. Here we are getting 3 into 5 into 7. 243. When we are dividing by 3, 81, again by 3, 27, 9, 3. So we are getting 5 times 3, 320. Here we are getting 6 times 2 and 1, 5. 141, directly 3 into 47. 1728. Here we are getting 6 times 2 and 3 times 3. So these are the prime factorization of the numbers. That means the given number we can write as the product of prime numbers. Next, number 729. There we are getting 6 times 3. 1024. Here 10 times 2. 1331, 3 times 11. 1000, 3 times 2 and 3 times 5. It's the prime factorization of all the given numbers. Second question, the prime factorization of a number has 1, 2, 2 3's and 1 11. What is the number? So we have to multiply all the prime numbers. So we can write the required number is 1, 2, 2 times 3 and 1, 11. When we are multiplying this, we will get 198. So 198 is the number. Now third question, find 3 prime numbers all less than 30 whose product is 1955. So to find the prime numbers of this product, we have to factorize that, to prime factorize that. When we are doing the prime factorization, this is an odd number, so we cannot divide by 2. We know that the first prime number is 2. So check the number by 2. It's an odd number, so we cannot divide by 2. Next we check with 3, and after that next one 5. So here we are taking 5, dividing. This number is divisible by 5. So when we will get 391. After that by 70, then by 23. So here we can see the prime numbers 5, 17 and 23 are less than 30 and whose product is 1955. So these are the numbers. Fourth question, find the prime factorization of these numbers without multiplying. First here 56 into 2, 25, product of two numbers. So we have to write the prime factorization of both the numbers. 56 we can write as 56 when we are dividing by 2, it will come here in 5, 2 times 16, there it will come 8, again by 2, 14, again by 2, 7, and divide by 7, it will come 1. That means 3, 2 and 7. 25 we know that 5 into 5. Then prime factorization of 56 into 25, it will come 3 times 2 and 2 times 5, then 7. Same way the next numbers, 108 into 75. 108 we can split as 2 into 2 into 3 into 3 into 3. 75 as 3 into 5 into 5. Then prime factorization of this both the numbers. So 108 into 75 is here 2 times 2 and 3 plus 1, 4 times 3, 2 times 5. Next number 1000 into 81. 1000 we can write as 3 2's and 3 5's. 81 as 4 3's. Then prime factorization of the product 1000 into 81 is here 3 2, 4 3 and 3 5's. Question number 5. What is the smallest number whose prime factorization has 3 different prime numbers? 3 different prime numbers. The smallest number we have to find. So we have to multiply the smallest prime numbers. First prime number, that is 2, then 3, then 5. So we can write the smallest 3 different prime numbers, which means 2, 3 and 5. So the smallest number whose prime factorization has 3 different prime numbers is 2 into 3 into 5, that means 30. Second part, 4 different prime numbers. So we have to take the smallest 4 prime numbers, the first 4 prime numbers, 2, 3, 5 and 7. Then the smallest number whose prime factorization has 4 different prime numbers, which means 2 into 3 into 5 into 7 is equal to 210.